In this video, we'll take a look at some of the things that can get in the way of a good model or some of our predicting power. So we'll start right here with a quick look at causation. So maybe we think there's a direct cause and effect relationship between two variables, like the amount of artificial sweetener in this rat's diet and this amount of tumor. So we think that this sweetener is causing cancer, right? We see something like this a lot. But the idea here is it's very hard to conclude some kind of causation without a very, very careful experiment. That's why we've been talking about experiments for a little while. So one of the things that can kind of get in our way of all this are what are called lurking variables, which basically means it's not the x or the y variable, right, the explanatory or response variable, but it may be responsible for changes in both variables. So here's a positive, strong linear relationship between ministers in Boston and the barrels of rum sold. So are we to conclude then that the number of ministers in Boston is explaining why the rum consumption is going up? And although some of us might laugh and be tempted to say, well, yes, ministers are causing that, or maybe because there's so much rum, then we can switch it around. Maybe if we switch the X and the Y here, then well, more rum's getting sold, so more ministers are going into the, more people are going into the ministry. But if we think about this for a minute, there's another variable that's back there. And if we think about it, what would cause both of those to also go up? And then over time, population is going to increase. So that's going to tell us that the number of ministers and the number of barrels of rum that are being sold, right, alcohol consumption and the number of ministers are going to go up as population increases. So population becomes a lurking variable here, right? So we have to be very careful as we start to look at this, because correlation and causation, they're not necessarily one and the same. So correlation doesn't imply causation all the time. Again, I'm going to repeat myself. Correlation does not imply causation. Causation is going to come when we set up a very, very a well set up experiment. That's where we can start to really see, because again, what we're doing, if you think back about the experiments, we could set up some kind of control, right? We had a lot more control in an experiment, and we could start to think about, all right, what are some of these lurking variables that might affect what we want the outcome of this to be, what's an element that we could block for or stratify for on the front side. So two types of lurking variables that we'll look at, and really these can both be present. So the first one is a common response, which is an association between, where we're looking at high school students' SAT scores in their first year GPA. So we think that there's this relationship here. But maybe there's a third variable involved, right? Typically, a good SAT score correlates well with your GPA, but maybe there's something. Is there something else that could be in common with both of these? In other words, is there this idea of Z which could affect both of those? Maybe someone's study habits, maybe your IQ, maybe you get a high SAT score because you got a high IQ, and that also translates well into your GPA. Maybe your study habits have related both to either, a very good SAT leading to very good GPA, or you have poor study habits, so you had a low SAT and you have a low GPA. The other type of lurking variable is what's called confounding. So this is the effect on a response variable. Again, we're not quite sure, is it one or the other? Um, so we got this person regularly attends religious service, and then how long they live. So we think that, typically maybe those folks going to church services have a tendency to live a little bit longer. Um, so the idea with confounding, again, the effects on the response variable over here at y, this is the response variable, right? We don't know if it was the original x, or maybe there's this other variable z that could also be affecting it. So that maybe the religious people just have a healthier lifestyle. What you should notice with confounding, we have this, the religious people are in both of them, but we don't know if they're living longer because they go to church, or maybe they just have a healthier lifestyle. So there's a relationship between X and Z, but we can't tell, is it the fact that the religious people are going to services, or maybe it's the fact that they just live a healthier lifestyle, but it's out of that same group of people. There's where confounding kind of makes a difference. So you look back at the original example, barrels of rum sold and the ministers in Boston, right? Do we think that the number of ministers in Boston, if that's the X, do we think that's what's causing the y, and here actually both of these are affected by a third variable, which is population. So in this particular example, we're looking at a common response situation where there's this variable that affects both x and y. So a couple quick examples. Does TV make you live longer? So let's say there's high positive correlation that if you have TV, you live longer. So there's TV, and we'll just call it life expectancy, LE, life expectancy. So does TV make you live longer? Is there something else down here that could also affect that? Well, let's think about this for a minute. Probably, you know, countries with more money probably have more TV sets. So if a country has more money, higher socioeconomic levels, they have more TVs. They also have better medicine, which means they have a higher life expectancy. So a lurking variable here, right? All of a sudden people are trying to connect TV with life expectancy. Well, maybe that's not really it. Maybe living conditions could be the lurking variable here, right? Socioeconomic levels, the overall wealth of a country could be one of those lurking variables that cause both of those to go up. So not only is it a lurking variable, but it's also a common response lurking variable. Studies showed that women who work in the production of computer chips have a high number of miscarriages. So a union comes in and claiming that exposure to these chemicals causes the miscarriages. That's not out of the, it's not a strange thing to think about. So basically they're saying the chemicals cause the miscarriage. Is there anything else that could be causing the miscarriage? Again, this is not an experiment, so we got to be careful with causation. We haven't set up a very, very careful experiment. We're not going to expose these pregnant women to chemicals, but if we look carefully, maybe there's something else that's kind of confounding this. Is there another variable that could cause the miscarriages in this situation? And so look back at your group. So we got these women working they're working in this production of computer chips. They're standing around on this line. Maybe it's standing. Maybe the women being on their feet all day also could cause the miscarriages. So at this point, we don't know, is it standing or is it the chemicals? We don't know which one's which. So there's this confounding variable, right? Because it only affects the second, the response variable, right? The standing would not affect the chemicals. So here's the lurking variable here would be standing, right? The lurking variable, which is down in that Z circle, would be standing. And in this particular case, more specifically, it's a confounding variable because we don't know, is it the standing or is it the chemicals? Look at one more example. So our grades in TV watching link. So children who watch many hours of television get lower grades than those who watch. So here we go, back to TV. Does TV cause low grades? Well, is there anything else that could play into this? Well, again, we can start looking at socioeconomic levels, right? Or parental involvement. You know, if parents aren't very involved, it's probably going to make TV hours go up and grades go down, right? So all of a sudden, parents could be in here, and that could affect both of those. At which point, parents would become a common response variable. So there's a few other ones that I'm going to throw at you. Children with lower IQ may watch more TV, and that. So again, back to kind of that IQ idea. That maybe they're just sharper students, don't watch as much TV, so they have the higher grades. And then maybe in the lower socioeconomic levels, you think parents are working more, which means that children that they're allowed to watch more TV because mom and dad aren't home because they're out working. Maybe it's something like that. So we'll look at one more. Ice cream and flu. So there's a negative correlation between the number of flu cases, right? You think about as the flu goes down, the amount of ice cream sold in that particular week might also go down. Is there anything? So obviously, if you want to get rid of the flu, you need to eat more ice cream. Or if we think about this for just a minute, when is it the most likely there's a lot of flu? Well, more ice cream is sold in warmer times when there's less flu. Conversely, when there's colder weather, not as much ice cream, more cases of the flu. So the lurking variable here would be the weather. So I can put W, and that would affect both of those. So there's where we get a common response.